Hey, so I'm doing a repair today, and I'm gonna try to do a video walkthrough of the repair process. I have a friend, he called me maybe a week and a half ago. He was explaining that he's got a drum sander and I guess the jack that lifts the table up and down is bolted into aluminum casted motor mount. And I guess just from repeated use and adjustment over time, the steel jack screw stripped out the threaded hole in this aluminum casting. And so it's pretty common. Like in general, for mechanical design, you wouldn't even thread a hole into aluminum. Why they chose to do this on this specific drum sander is kind of beyond me, but it's bad practice. You can get away with it in some cases, but if there's actual, like a mechanical loads getting applied, or especially anything where you are going to be installing or removing or adjusting a screw repeatedly, basically it'll damage the threads eventually on the aluminum part. I mean, aluminum's really soft, where something like steel, harder materials, titanium, Inconel, very robust for threading. Anyway, let me get into it. Okay, here's the part. You can see down into this bore here, threads, forms have been damaged. They're all boxed off, and yeah, they're no longer creating any kind of resistance to the bolt going through. And so there's this tiny little lug here that they threaded into, and it is, I guess, just through repeated use, has gotten tired over time. This is the jack screw that goes down in here, and let me see if I can do this with one hand, but you could basically just push this through at this point. So the threads are gone, and this thing needs a rehab. So the way that we do this, there's a couple options you could do. Number one is called a Helicoil. For this specific application, because the screw is going to be like inserted and removed multiple times, I was concerned about putting a Helicoil in here because of the way they're designed. There's not really great retention, and so the concern is, when you're backing it off, it could just take that Helicoil with it. There's another thing called a tie insert, which is sort of a cornier version of a Helicoil. It came with some of the same problems. And then the third thing was a key insert. A key insert is basically like a threaded bushing that goes down this hole, and then it has some tangs that stick off of it. I'll show a picture of that. And once you get it driven in, there's a tool, and you pound the tangs down into the aluminum part, and it spoils these threads and keeps that insert from backing out. That would have been the best structural solution for something like this. After taking some measurements, though, I started to worry because this lug here is about a little over half an inch thick, and the key inserts, I think the smallest one I could find was somewhere around an inch long. And so there'd be quite a bit of unsupported stick out down here at the bottom. And, it could cause problems on its own, just having that unsupported length that's not backed up by any material and then twisting around on it. I mean, the tines will probably keep it engaged in the hole, but it seemed risky to me, so we kind of went back to the Helicoil idea. So let me show you what I have. Okay, this is a coil thread repair kit, similar to Helicoil. They seem pretty good quality from what I've seen. So they come in a kit. Okay, so the first most important thing here is this little device. This is the Helicoil, and so it's, like I said, it's threaded on the inside, and so it carries that thread form on the ID, and then there's a different thread on the outside. And so what you do, and this kit comes with the appropriate drill size here, so you can basically, you're gonna have to plus size this hole that's in here already and bore that out to get rid of those old threads, and then you're adding some diameter to it by putting that coil insert down in there. So you need to bring it to the right ID or diameter, and so that's what this drill bit is for. And then the second part of that is this Helicoil tap. Now these are special taps. I want to say they're proprietary. Okay, this is 18 UNF. The hole size is 5/8 by 18. So this tap corresponds with a Helicoil repair, and so you drill it out with this, tap the hole with this insert. This insert accommodates a 5/8 inch Helicoil. Okay, so this kit cost me about right around $100. So the last thing is this. And so the way it works is you use this tool here, and it grabs onto this tang, and it allows you to like twist it so that it threads down to that hole. And once it gets to where you get it flushed up and bottomed out in the hole, use this to snap this tang off. Yeah, so this, see how it has that little crack starter there on that last thread? So that basically makes it possible to break that tang off. And so it has like sort of a pre-existing frangible component there that allows this tang to be broken off. And then once it's in the hole, it's there. So anyway, to resolve my concern of it backing out, I'm gonna install this with I have some pretty heavy duty Loctite that is used generally for bushings to help keep them glued in place. And so that's what I'm gonna use on here. One of the concerns I have with this is that, you know, when I drill this new hole, this aluminum's so soft that I could wow it out or make it egged or elongated. And if it doesn't go in straight, when he puts this back on the machine and the little jack is trying to go up and down, it may wind up with a binding condition. And so the first thing I'm gonna do is turn a part that I could put in here, and I'll key it up so I can put it in the jaws of my chuck on my Bridgeport, just to square it up to the surface. And that'll let me set this in place so that it's orthogonal to that cutter. And then I'll drill the hole orthogonal to this face and then tap and install the helicoil, and it'll be square to the world and work when it gets put back on there. Okay, I just happen to have this little piece of material here. It's just garbage stock that I keep in the bin for stuff like this. It's already got like a little starter rebate on this end here, so I'm gonna just take advantage of that. I'll clean this up, and then I'll skin this and measure it and bring it down to the diameter of this hole so that I can just sort of drop it in there. And I'll explain this further as I don't have a bore gauge big enough to, or this size to really measure this. So I'm just gonna use some calipers. I'm gonna get a rough measurement here just to get me in the ballpark, and then I'm gonna use that as a reference. And then as I sneak up on that dimension, I'll just use this part as a fit check to the part that I'm turning. But it looks like I got about, I'll call it 0.6. See what? Okay, I got that part on there. I'm about to use this cutoff tool. It really likes to be square, so I'm just checking to see that it's square to the chuck, and it looks pretty good. Is that here? Is that the break? That's right. Let's see if we can find it. Where'd it go? There we are. Oh, shit. Okay, so got this. Okay. Oh. All right, should be good. Good enough with it. Okay, I ran into a little problem here. I'm at the bottom of my adjustment on this knee, so I got it dropped way down. This part's just too tall to have the chuck and the drill bit on there. So what I'm gonna have to do is pivot, and I'm gonna do this setup here where I have an R8 collet, and this just happens to be 1/2 inch, so I have the right collet for it. So I'll take that chuck out, and everything should work. What I just did in the other frame is I kind of use this to line this up, and then I set 0 here on my DRO so that I could find my position back to that. And you can see this slides down in there like very nicely. So I'm pretty confident that I'm not doing anything to make that hole worse than it already is. All right, we're gonna try that again. Okay. lock it back onto the hole position. Okay. All right. Okay, let me see what speed I got on here. I'm just turning it down because this isn't very well supported. All right. So the bore is nice and clean. Let me deburr that real quick, and then I'll tap this bad boy. Okay, I'm using this little springy thing here to help keep the tap centered in that hole so it doesn't waller around. Yeah, unfortunately I don't have a tap this large. So let me get you in here. We're just gonna do our best. I'm using this. Cutting pretty clean. Feels pretty good. I'm gonna move so you can see what I'm doing. Feels pretty easy. Just poke it out the bottom. And I think that's it. Give it a couple more turns. Yep, feels good. All right, let's take a look at that. Okay, those threads turned out pretty good. I see some dark spots down in there. There might be some porosity in the casting. I mean, this is another reason why you really don't want to be threading into a casting, but the threads formed really, really well with that tap. I went ahead and broke this edge here just to make sure there's not a burr on there. And then I cleaned this out with Kim Tool, basic carb cleaner, to get all the WD-40 and grease and whatever else may be in there out. Because I'm gonna install this with some block. Try this stuff here. It's retaining compound is what it's called. Cylindrical metal component retainer, R680. It's kind of expensive and high strength, permanent, medium viscosity, high temperature resistant, oil resistant. And so usually you use these on bearings, like you can see a little bearing there in the picture. Like if you have a bearing, it's a little sloppy, you can install it with this and it'll keep everything sort of sorted out. And so I'm gonna do a practice run with that Helicoil. I'm gonna try to get it all the way down through there. I just contaminated that with my dirty finger. I'm gonna try to get it all the way down through there, just see how easy or difficult it's gonna be. And then I'm gonna push it out the bottom. And then the second time I'm gonna do it with this. And once it gets in the hole, she ain't coming out. Like I was showing you before, there's this Helicoil here and little tang on it. And then this tool here, it's basically got a shaft and then there's a slot through the middle of it. And it fits, let's try to do this so you can see. It fits like that. And so if you could imagine like a slinky, and as you twist on this, the diameter gets smaller and it helps lead it in, you know? And then like if you were trying to back it out, it would actually try to make this OD get larger, which could be a problem. They have extractors for these too, but let's see how hard it is to get in here. Is it gonna thread? Come on, baby. I'm having trouble. What the fuck? Maybe I gotta get caught on the first thread. Yeah, there we go. Okay, she's going. Yeah, it's gonna go all the way through. Okay, it feels easy. Okay, while I have this here, I'm gonna put it in just a little more. I'm gonna see if this jack, how well it interfaces. I'm just gonna thread it in a little bit to see how it does. Just curious if I'm gonna get a bunch of mechanical resistance from this or nope. Wow, okay. All right. So I'm just gonna twist this down in here and go ahead and get that helicoil all the way out. All right, let me clean this off again and then we'll start over with the thread locker. I just wanted to do that just to see if it was gonna give me any issues. All right, this stuff is so thick that I'm just gonna use an applicator to kind of oh, Jesus. It's kind of expensive too, whoops. Let's see if I clean that off a little bit. All right, so stand by. I'm gonna get some roach clips. Okay, I'm just gonna hold this by the roach clip. I'm just gonna paint around the outside here. Get on. Oh, shit. I'm gonna go across those threads so I'll fill them up, and all this is gonna squeeze out at the end. All right, now I'm gonna do this whole. I can see it's buttered up in there. All right. And hopefully that's a good bond all the way across. Okay. Let's try this again. Hopefully it's not more difficult than it was before. It's like follow it, so looking out. You can see. You can see really opposite. I'm watching a lot less around. Anyway, turn the thing up. Yeah. Okay, I'm gonna just push this tang down. Was that it? Okay, it deformed. Here, let me turn it over so you can see. So it deformed right there. Let me see if I could just wiggle that loose. And that was it. It's gone. Okay, this looks pretty good. Okay, so could barely even tell that something's in there. Anyway, that's all I got. I'm gonna call him, let him know it's ready. I think I'm going to let this sit for about 24 hours, and then I'll thread that rod back in here and make sure everything's fine. But I'm pretty happy with the way this turned out. I mean, inside of the threads look really good. It's steel on steel now, so it should be pretty robust. There's a little bit of that thread locker down there, but it shouldn't hurt anything. Let's go ahead and try it. Yeah, feels really nice. It's like a very good mechanical connection, but there's no friction. And I'm pushing out some of that thread locker on the other side. Let me wipe that down. Could feel it like a little bit dripping out here on the bottom. Yeah, that's really good. Okay. That is all I got. All right. Yeah, so the main thing I wanted to explain is, first and foremost, I see a lot of people, drilling holes in aluminum. I mean, bolting through is probably fine, but to actually run threads in them, you could do it for certain things, like if you're making Halloween decorations or whatever, but if it's anything that's structural, you might want to think twice about it, especially if it's anything important or that you're worried about breaking down. Another thing is aluminum's soft, so if you take something really hard and you thread through a piece of soft aluminum, the aluminum's going to take the beating. It's literally the sacrificial part, and so sometimes you do that on purpose, make your cheap part disposable, so you drive all the wear to one side of the interface. Or you could do something like this where you have a threaded insert in the aluminum. Like imagine if you can't make the part out of steel for weight or whatever other reason, you could put a threaded insert, either a Keynsert, Helicoil, Easy Lock apparently. Like I said, there's another one called a Timesert. I've never used them, or some other kind of threaded bushing. And especially for repairs, if you're like, get a bolt stuck in your truck or something in the frame and it spoils the threads, you can drill it out and put a helicoil in there, as long as it's not like, you need enough wall thickness to support it, et cetera, et cetera. But there's some options out there to repair stuff like this. And so anyway, I mainly wanted to show how to do it and discuss those options. So anyway, that's all I got. Appreciate it.